These two shapes represent the closest apart two particles can be without touching. And the actual shape is the star tetrahedron held inside, and this is a star tetrahedron. But it can be held in this way, and the two particles can actually, the two reds are not touching. Oh man, is that not beautiful? And that's the shape of the two particles, not touching. Now in there's also the square. If you connect all four corners of that star tetrahedron inside, you get a square. So that's where the cross is hidden. But that's the closest two particles can be without touching. And we have the proof of that we see in a two-dimensional way right there. And that is because the star tetrahedron that's held in both is being transformed into the box and the tetrahedron. And the tetrahedron is being held by the two tetrahedrons. The star tetrahedron is being held by two tetrahedrons. So that's beautiful right there. It just lines up perfect. And we can see the shape is right there. The red is inside the red, but they're not touching. The yellow, the star tetrahedron has transformed. There's 1, 2, 3, 4, 5, 6, which are the 6 of the yellow, but they've transformed into the square. So this star tetrahedron has expressed itself as the square observing this tetrahedron. By taking the star tetrahedron and changing those shapes, by losing a little bit of speed, changing that speed into matter, equals mc squared, the tetrahedron is allowed to be inside of itself while still being observed as separate. Inside of the square box is where the cross is held. The box unboxed is the cross. So the cross is held there. And if we can just imagine what the cross would look like when we look down it, the actual square would encompass all of it. It's beautiful. And this is built on the same 6:1 ratio. That's a two-dimensional representation of the three-dimensional representation of the two star tetrahedrons being observing each other. When they observe each other, they create that third observation of the square. And that square is transformed from the yellow. So the yellow tetrahedron of the particle on the right, if they both were the exact same star tetrahedrons, this is a star tetrahedron inside here, this is two extra tetrahedrons on the outside. If this is the same style tetrahedron, the yellow would be transformed into the blue. The 6 of the blue would be the 6 of the tetrahedron that was transformed. Two particles being as close as possible. We're not going to talk about the spinning process that get this in here. We're just going to model it without movement. That's beautiful. And notice the red is bigger on all points, but the blue covers all of the yellow. It's beautiful. Wahiguru. Wahiguru. Wahiguru.